So what we're going to do in this video is we're extending an earlier video. So hopefully you watched part one. We're going to talk about separation of variables, and we're going to specifically look at this equation right here to start. Dy dx equals negative x over y, and hopefully it'll make sense what the solution to this is based on what we have here from the slope field work we did in the previous video. So separation of variables. I guess that I should come up here and talk about this right here. I said we could integrate this left side and get y, and that we could integrate the right side and get this. And that was like mostly true, but sort of I skipped some steps or I glossed over some things that that may be apparent after this. So let's go into more detail about how we integrate these types of equations. So what I want you to see is that if I were to try to do an integral on the left side and an integral on the right side like we did up above, I would run into problems because I can't really integrate this. What am I even integrating with respect to? So, is it x or is it y? So what we can do here is separate the variables. We have y here and y here, and then we have x here and x here. So what we want to do is get all the x's on one side and all the y's on the other. Typically, you get the x's on this side and you get the y's on this side. And I think you'll see why that's true as we move along. But what we need to do is I'll just rewrite this dy dx equals negative x over y. The easiest way to separate variables here, to think about it, I think, is to simply cross multiply. If I multiply the y over here, I get y times dy, and if I multiply by the dx on both sides, I get negative x times dx. It's totally fine to multiply by these different pieces the way we've done here. So I can separate this dy dx and multiply by the dx. That is the step of separating the variables in this equation right here. And then what it allows me to do is to integrate both sides, and I'm going to put this integral right there, to integrate both sides independently. The right side is some simple power rule. I get negative x squared over 2 plus a constant. That is just an integral that you should be able to do. And it's because I'm integrating an x equation with respect to x. The question becomes, how do we integrate this? Well, it's the exact same process. I've got the integral of y with respect to y. And notice it's the same thing as what I had over here, except for there's no negative. So when I do that, I just do power rule on the y, and it gives me y squared over 2. Now, I'm going to call this c sub x and plus c sub y. What I want to argue to you now is that we only need this c right here. You will not write this in the future because we don't need to do the plus c on that side. Here's why. Say c sub y was equal to 1 and c sub x was equal to 10. Couldn't we just move this 1 over to the right side and have a 9 over here? Say c sub 1 was 3 and c sub x was 10. Couldn't I just move the 3 over to the right side and put a 7 here? I think that you should see that for any combination of c values right here and right here, I could always condense them onto one side. So we don't write this, c sub y, and what we do over here is we just write c. So the typical way to do these is to just write the c on the x side. So from there, I could multiply by 2, and I would get y squared equals negative x squared plus 2 times c. And usually when we solve these equations, we want to solve for y. But in this particular equation, I want you to see that, well, we already did the separation of variables, that the separation of variables technique matches what we got up here. Do you know the equation of a circle? You did it in Algebra 2. You probably did it in pre-calculus. It is x squared plus y squared equals r squared. So for example, x squared plus y squared is 1 would be the unit circle. X squared plus y squared equals 25 would be a circle of radius 5. So if I come down here, what I want you to see, I can move this over to the left side. And I could get x squared plus y squared equals 2 times a constant. And there are ways to deal with this that I'm not going to get into right now. But notice that sort of looks like this. And the question becomes, well, how would we get different circles? Well, what if c was equal to, actually I'm going to do this over here. What if c was equal to 1/2? Well, we would get x squared plus y squared is equal to 1. And you may say, hey, how can you just say, let's let c equal 1/2? Well, if you remember back to the one that we started with, the 2x, it integrated to x squared. And I just put some different c values in here. Well, it integrated to x squared plus c. This is c equals 0. C equals -1, -2, -5, and it gave me different parabolas that fit this thing. So we can just choose arbitrary c's, and they would be representative of specific, particular solutions to the differential equation. So let's go back. When I choose c equals 1/2, it gives me a circle of radius 1. What if I were to choose c equal to 2? X squared plus y squared equals 4. Well, that's a circle of radius 2. What if I were to choose c equal to 4.5? Why did I choose c equals 4.5? Because when I double 4.5, I get x squared plus y squared equals 2 times 4.5 is 9. And that gives me r equals 3. If I were to take c equal to, what do you think the next one's going to be? 8. I would get x squared plus y squared equals 16. And that would give me a circle of radius 4. So this solution that we get by separating variables and integrating the left and right sides independently gives us solutions dependent on the c value that are different circles that have different radius. So it matches what we got in the slope field. And I hope you see that. I hope you can make a connection between this matching up with this thing and this separation of variables technique. So let's go and do separation of variables on something on a different equation. If you remember in the beginning, I actually gave you 3 differential equations. This one, and this one. And we're going to go ahead and do this example number 2. I guess I'll say real quickly, this one right here, I think that we can easily say, all right, well, you integrate this, and you integrate this, and you get x squared plus c. But I want you to see that we could actually use separation of variables. If I have dy dx equals 2x, I can multiply it by dx and get dy equals 2x dx. Integrate this side, get x squared plus c, and then integrate this side at the same time, because what I do to one side, we do to the other. And this is the integral of 1 times dy, which you can think that as power rule if you want, but you get y. So this idea of separation of variables actually sort of applies to this one too, but we don't necessarily need it to see it. So let's do this one down below. All right. So in this one, we're finding the general solution. I didn't give you any points that it goes through, so our answer is going to have a C in it. So let's separate the variables. I'm going to do the same thing where I multiply by the dx, but I also need to get rid of this, and in order to do that, I'm going to divide by y squared. So that's going to give me dy over y squared is equal to x times dx. So there is something that is sort of a trap here. I'm going to integrate this. I'm going to integrate this. The right side is definitely going to give me 1/2 x squared plus a constant. The y, or the left side, people want to mistakenly, and I talked about this recently in class, write ln absolute value of y squared because that's in the denominator. But notice the u and the du don't match up there. I need to use power rule. I need to look at this as the integral of y to the -2 dy. That is a crazy, crazy common error to do an ln there. So try not to fall for that trap. So we have y to the -2. What's that take me up to? It's y to the -1, and then I got to do 1 over that -1. So I can rewrite this as -1 over y is equal to 1/2 x squared plus a constant. Now, I didn't really include directions in this example, but usually we want to find y equals f of x. We are typically asked for a solution to this differential equation in the form of y equals f of x. What this means is that one, we want it to be in a y equals form, and two, we only want x's and numbers and division and whatever, right? We don't want any y's on the right-hand side. So we want a y on the left side and equals, not a 1 over y equals, and we want to have all x terms in the expression on the right-hand side. So you can see that this one's not like that. And I don't know, there's lots of ways to talk about this. Again, I will show you the wrong way to do this first. The wrong way to do this would be to flip the y, the left-hand side, and I'll write it as y over -1 equals, and then to flip each individual piece, right? So what would it be like? 2 over x squared plus 1 over c. This is wrong, and that's because it's just not the way that numbers work. For example, we know that 3 plus 1 is equal to 4. If I were to do that same flip thing that we did over there to get this, I would get 1 over 3 plus 1 over 1 equals 1 over 4. And look at this. This is really just 1. And I know that 1 plus 1/3 doesn't give me a fourth. So that should demonstrate to you that I can't just flip individual pieces. What I can do is flip the entirety of it. So if I had 3 plus 1 equals 4, I could flip it, and 1 over 3 plus 1 equals 1 over 4, right? So you should see that that would still give me 1/4 equals 1/4, and that's okay. So that's actually what I'm going to do here. I'm going to do that flip. I'm going to flip this left side. That's going to give me negative y over 1 equals, and I'm going to do 1 over the entirety of the right side. So if I do that, I get 1/2 x squared plus a constant. And now what I can do is, and hopefully you should see that doing this operation, or getting that line that I just boxed from this line right here is the same as what I did from here to here, and that's legitimate math to do. Now I can just multiply by a -1 and get y equals -1 over 1/2 x squared plus a constant. Now, there's one more thing that bothers me in this equation. If this is a free response question, you would get credit for it at this point, but I don't like having this fraction inside of a fraction. If it was a multiple choice question, we want to get to the answer that the AP would give us, and I don't think that they would leave it in this form. So the easiest way to think about this, again, this is like basic math lesson in calculus, I'm going to multiply by 2 over 2. Why is that? Because that's another form of 1, and it doesn't change the fraction. And watch what happens. I get a -2 in the top, but when I distribute this 2 into the bottom, this 2 cancels with the half and gives me x squared, and then this 2 goes in here and gives me plus 2c. So this is my y equals f of x equation. And there are other forms in which we could look at this thing right here, but for now, I'm good with you being able to get to this spot right here, or even if that 2 over 2, especially if it doesn't come intuitively, if you get to this, that's also good. I really need you to be able to look at an equation, see how to separate the variables, integrate both sides correctly, and then solve for the y. So hopefully that's good. I will see you soon. Thank you.